So for this video, we're going to be talking about absolute value inequalities. So an absolute value inequality is an inequality that contains an absolute value. And if you recall from our absolute value lesson from before, the absolute value of, for instance, x equals 1 means the distance between x and 0 is 1. And now we can also look at these inequalities of absolute value and look at what that means. So for instance, that the absolute value of x is less than 1, that means the distance between x and 0 is less than 1. And to graph that, I would get this and inequality. And then if I had the absolute value of x is greater than 1, that means the distance between x and 0 is more than 1. And I get this for compound inequality. So to go about solving these absolute value inequalities, it's pretty similar to what we do when we're solving equations. We have a couple more steps. So for instance, if we were to solve the absolute value of ax plus b is less than c, we would actually be solving it in a compound inequality. And so there's something considerably different that we're going to be doing here compared to the equation because of our inequality. We're still going to be doing the same thing of having one of the inequalities having the opposite answer like we did for the equation. So one of them was the positive, the other is the negative. But you'll notice here I also flip the inequalities for the one I'm changing the sign of the answer. Instead of it being less than, like it was up here, I'll flip it to being greater than an and then my second inequality is going to be the same thing from our original problem, but this is at the opposite value. And then you'll notice the same thing here. So to solve ax plus b, absolute value is greater than c, I'm going to rewrite the first one to have the negative or opposite sign as my answer. And then I'm going to flip that inequality. And the second inequality is just going to be the same thing. The important thing to remember here is that if we have a less than inequality, that's going to end up being an and compound inequality that we're solving. If we have a greater than at the beginning, that's going to be an or compound inequality that we're solving. So let's look at some examples. I'm going to solve the inequality and then graph each solution if possible. So first I have the absolute value of x plus 7 is less than or equal to 2. So I have a less than or equal to, so I know that's going to be an and, like I have written up there. And so my first step is I'm going to drop the inequality, so I have x plus 7. I'm going to flip this inequality to be greater than or equal to, and then I'm going to change the positive 2 to be negative 2. And then my second inequality is just going to be how it is written, but without the absolute value sign. Solving this first one, I'm going to subtract 7 from both sides. And I get x is greater than or equal to negative 9. Solving the second one, I'm going to subtract 7 from both sides. And I get x is less than or equal to negative 5. And so then I can go ahead and write that as one compound inequality. And that would be negative 9 is less than or equal to x, which is less than or equal to negative 5. And then I can go ahead and graph that. Here I have both less than or equal to, so it's going to be closed circles. And since this is an and, I'm going to go ahead and connect them. So that means that x can be anywhere between these two numbers. Okay, let's try another one. So I have 8x minus 7 absolute value is less than 0. So here we have to remember something really important about absolute values, and that was that the absolute value of any number has to be greater than 0. It cannot be a negative number. And now this problem is saying that my absolute value is going to be less than 0. It's going to be negative. And since we can't have that, that means that this is going to be no solution. I'm going to say absolute value can't be negative. Let's look one more for this video. Here I have the absolute value of x minus 1 is greater than or equal to 5. I'm having a greater than or equal to, so I know it's going to be an or statement for my compound inequality. So I'm going to first write my compound inequality with the opposite answer. And so since I'm taking the opposite sign of 5, I have to flip this inequality. So I have a less than or equal to negative 5. Or I'm going to leave everything the same. Solving this first one, I'm going to add 1 to both sides. And I get x is less than or equal to negative 4. Add 1 to both sides. And I get that x is greater than or equal to 6. And so now, graphing that, I have greater than or equal to, so it's going to be closed circles. The first one is less than or equal to negative 4, so I'm going to draw my arrow pointing to everything less. The second one is greater than or equal to 6, I'm going to draw my arrow for everything bigger.